At this point, we now know how to graph an inequality by graphing the boundary condition, shading in the appropriate place. And so now what we're going to do, since we are armed with this knowledge, is we're going to learn how to solve what are called systems of equations and inequalities. And we're only going to do that using graphs. There are many ways to do this algebraically. However, you saw those in middle school. And during this time, we are going to focus on graphing only. And I'm going to start with finding the solutions to equations, and then we are going to generalize that knowledge into how we would find the solutions of systems of inequalities. So let's start with this system. Y equals 3x minus 4 and y equals negative 2x plus 1. So the reason I call this a system of equations is that I have more than one equation. And so what I am doing is I am looking for a solution that makes both equations true at the same time. So the first thing I need to do is to be able to graph each one of these. So let's start by graphing y equals 3x minus 4. And that graph would look something like that. Now, I also need to graph y equals negative 2x plus 1, which looks like that. Now I've done that very quickly, but you know the technique for graphing these. Find the y-intercept, use the slope to find another point, draw that line. But the surprising part comes from when I graph both of them at the same time. And this is how we're going to solve our systems of equations and inequalities. We want to graph both of the equations or inequalities in the system at the same time. And when I realize that what I'm looking for is one point that is a solution to both systems, it makes the answer just a little bit obvious. So here I'm going to have the line y equals 3x minus 4 and y equals negative 2x plus 1, and every point on the line is a solution to that particular equation. For example, the point 0, 1 is a solution to y equals negative 2x plus 1 because it is on that line. Likewise, the point 2, 2 is a solution to y equals 3x minus 4 because it is on that line. So what I am looking for is I'm looking for the point that lies on both lines. So in this case, the point 1, negative 1. And I can verify by substituting those into my two expressions that that is the ordered pair that will make both of those true. So in essence, when I'm solving a system of equations, I want to graph the two of them and find the place where they intersect. Let's do this again, but now for two different equations. 5x plus y equals 1. This is in standard form. We know how to graph that. We're going to find our intercepts and graph it accordingly. So there we go. We've got this one. Notice that our x-intercept is a fraction, but that's quite all right. And we have the line x equals 1. Now we haven't talked about these in a very long time, but remember, if an equation is x equals some number, it is straight up and down vertically. And if it is y equals some number, it is going to be horizontal. So this would be a vertical line there, and I want to graph them both at the same time, and the solution to the inequality is the place where my two lines overlap. In this case, 1, negative 4. And what I can see is that if I substitute those numbers in to both equations, I can see that it makes both equations true at exactly the same time. And that is the solution to a system. It's that point which makes all of the equations or inequalities in the system true at the same time. Next up, I'm going to look at a system composed of two standard form equations. So I have x minus y is equal to 2, which is going to look like that. And x minus y is equal to 4. So when I graph it, it's going to look like this. So what I want is once I graph these two, I need to know where they cross, where they intersect, where they overlap, And you can sort of see the problem here. These two don't overlap ever. They're what are called parallel lines. Parallel lines have the same slope and they never ever intersect. Think about railroad tracks. Bad news if those ever intersect. And so in this case, since they are not going to intersect, there is no solution to this system of equations. Now we're going to repeat the same idea for inequalities. Let's take the inequalities, or the system of inequalities, because we got two of them. Y is less than or equal to negative 2x minus 3. So when I graph it, that's going to look like this. I'm shading the region below the boundary, and I'm shading the boundary itself, so the less than section and the equal to section. And I have y is less than 3x plus 2. So in this case, I'm only shading the region below the boundary and not the boundary itself. And just like I did with a system of equations, I want to graph them both at the same time. And what you'll see when I do this is that there is one section of the graph, this triangle, where I have shaded in both of my inequalities. And that area right there is going to represent the solution to the system of inequalities. Now, when I had a system of equations, I always presented my solution as an ordered pair, x and y are, and then giving the ordered pair that was the solution. However, when you present the solution to a system of inequalities, all you need to show is the graph. There's not really anything to write, and it's understood that the area that is shaded in from both graphs is going to be my solution. Now, if you are doing this by pencil, it can be kind of difficult to show the area that is shaded in twice. So let me make this suggestion. With one of your functions, shade by just drawing multiple lines up and down. So just a series of vertical sketches. And then for the other function, shade with horizontal lines back and forth. And then what you'll see is that your area that is the solution to the system of inequalities is the area where you've shaded both left and right and up and down. But in any case, our solution is the area where they overlap. So let's do this again with a fresh set of inequalities. Here I have y is greater than or equal to negative 2/3 x minus 3. So that's going to look like this. Don't let yourself get in a panic over the slope being negative 2 over 3. Remember that slope is the change in y divided by the change in x. So here, from my y-intercept of negative 3, I'm going to go down 2 and to the right 3. So again, don't fret about that fraction. You know what to do there. Keep your wits about you. So we have that inequality, and I want to graph the other one as well. Y is greater than negative 1. Remember, if I have y and then some symbol and a number, that is going to graph as a horizontal line. And just as before, what I'm looking for is the area where I have shaded twice. Now on the computer, you have the advantage of seeing that red and blue together make purple, so we're looking for the purple section, which is this area right here. And notice that it includes this part of the line, but does not include that part of the line. So there's a whole lot of information presented here in a very compact way. Again, I would recommend shading one of the functions with vertical stripes and the other with horizontal, so it makes it easier to see where they overlap. But that entire area in purple represents our solution to this system of inequalities. Finally, one last weird situation to look at, because what would this be if I didn't show you the weird situations? What if we have the system of inequalities, y is greater than or equal to 2x plus 2, and y is less than or equal to 2x minus 1? If I graph both of them, here I can see y is greater than or equal to 2x plus 2, and here is y is less than or equal to 2x minus 1, you can see there is no purple happening here. There is no area where these two overlap. And in this situation, we would say there is simply no solution, because again, there is nowhere where these overlap. So to summarize, if we are solving a system of equations, we are looking for the ordered pair in which the equations intersect. So we are looking for an ordered pair that is on both lines, and when we find that, we present the answer as an ordered pair. If we are graphing a system of inequalities, we are looking for a region of the graph that is shaded for both functions. So we will have to graph both of them, shade both of them, and see what area we shaded over twice, and that entire area is our solution to the system of inequalities.